Hello everyone, my name is Lloyd Borrell. I'm the owner of the website electricsense.com and the author of the ebook How to Beat Electrical Sensitivity. I'm really happy that you've been able to join me today, and I'm looking forward to sharing some extremely valuable information with you. This is the first webinar in a 4-part series called A Step-by-Step Guide to Ultimate EMF Protection. So this is what I'm going to cover today. If you look on your screen here. So what I'm going to talk about is why EMF protection is so important, why I'm talking about this, what the biggest single obstacle is in achieving ultimate EMF protection, and I'm going to outline my systematic model for ultimate EMF protection, which forms the basis of my unique step-by-step approach for dealing with EMFs. If you're listening to this live, then on your screen you can see on the right hand side, you can see a question box in the GoToWebinar control panel. So you can type in your question there during the webinar, or you can ask your question at the end of the webinar in the Q&A session. What I'm sharing over the next 4 webinars is what I've learned in the last 10 years in my own journey of going from being extremely electrically sensitive to being able to live a normal life again. My goal is to share with you concrete, actionable steps that will get you results. This is what it's about, getting you results. And these are not just theories. There's a considerable body of science backing up the information presented in these webinars. So why is EMF protection so important? Well, to quote one of the pioneers on EMFs and health, you can read this on your screen, Nobel Prize nominee Dr. Robert Becker said, "The greatest polluting element in the Earth's environment is the proliferation of electromagnetic fields." There's 2 points I want to make here. Firstly, EMF exposures are escalating at an exponential rate as demand increases for wireless communications, and cell phone companies seek to satisfy this demand by offering ever more sophisticated services like 4G and 5G. And second point I want to make, existing exposure standards do not protect us. They don't protect me, they don't protect you from these exposures. They are set thousands, and in some cases hundreds of thousands of times higher than the level at which adverse biological effects have been found to occur. For instance, SAR, which means specific absorption rate, it's what's put in the packaging on cell phones in certain countries. It's the rate at which RF radiation, radio frequency radiation, is absorbed by the body. The ICNIRP standard, ICNIRP means International Commission on Non-Ionizing Radiation Protection. The ICNIRP standard is so it's the world standard if you want. It's 1.6 watts per kilo of tissue. But studies show adverse biological effects at levels as low as 0.0000021 watts per kilo. Yeah, have you got that? 0.0000021 watts per kilo. It's difficult to probably appreciate that, but it's to say that there are biological effects more than 100,000 times lower than the standards. Now there's a lot to be said on this, a lot more than what I've just said, but my aim in this webinar is not the why, it's the how. So I'm not going to try and convince you why you must take EMF protection seriously. I'm going to explain to you how it can be achieved, because I know that most of you following this webinar have already experienced some symptoms of electrical sensitivity, or you're sufficiently well informed on this subject to want to take the necessary steps to protect yourself from EMF exposures. Why am I doing this webinar? Why am I talking about this? Well, I feel I'm in a unique position to be able to help. I've first-hand experience of the effects of EMF exposures. Most of you know my story, but I became electrically sensitive back in 2002. I didn't even know what electrically sensitive was, or EMF was, or anything about this. I suffered extreme symptoms. I was so badly affected, I couldn't use my cell phone, I couldn't use my computer, couldn't go out in shopping malls, I couldn't go to public places, I couldn't even use my regular corded landline phone. I spent over 10 years researching the subject, looking for solutions, like a bloodhound, looking for solutions. And I've now recovered my health to the point where I can work, play, travel, socialize, and lead a normal life. This is what I want to share. All that I've learned about dealing with EMFs effectively so that you can deal with EMFs effectively. Now, the first thing I'm going to talk about is the number one concern. And I know what this is because this is what people ask me about all the time. Number one concern is what people ask me about. People's number one concern is how to achieve direct EMF protection. Direct, now they don't always put it in those terms. They don't say those words exactly, how to achieve direct EMF protection. This is what everybody's asking about. Direct EMF protection, okay, how to achieve it. So direct EMF protection resolves around understanding, measuring, and shielding from EMFs, from electromagnetic fields. And this is what I'm going to devote the first two webinars to. Because it's hugely important to get this right. If you've already got symptoms around EMFs, without rigorous direct EMF protection, you can't hope to deal with these symptoms. But here's the catch, and it's a huge catch, okay? Listen carefully. If you only apply rigorous EMF protection, you can't hope to make a significant recovery. Making a significant and sustainable recovery means looking at what I call the bigger picture. And ultimate EMF protection is exactly that, looking at the bigger picture. And that's what these 4 webinars are going to be covering, looking at the bigger picture. It's not just direct EMF protection. So it means looking beyond direct EMF protection and embracing a natural and holistic view of health. This is the key. By holistic view of health, I mean examining every aspect of the scenario, not just the EMFs in your personal environment, but implementing environmental, nutritional solutions and engaging in energy work. It's these aspects of a holistic view of health which form the basis of what I'll be covering in this webinar series. With that said, I'll come back to the bigger picture later, but for now I want to talk about direct EMF protection. So firstly, I just want to welcome any latecomers. If you're attending the webinar, you're in the webinar series, a step-by-step guide to ultimate EMF protection. There's a question box in the GoToWebinar control panel on the right of your screen, and you can type in your question there during the webinar, or you can ask your question at the end in the Q&A session. So direct EMF protection, where do you start? Another way of putting this is to say, what's the number one thing you need to do? What's the biggest single danger here? Well, I'll tell you what it's not. It's not radio frequency radiation, it's not magnetic fields, it's not electric fields, it's not dirty electricity, it's not cell phones, Wi-Fi, cell towers, smart meters, faulty wiring, and it's not microwave ovens. I'm making this point because this was, without doubt, the single most important obstacle in my recovery. And I know from the many hundreds of people I've talked to on this subject, it's the single most important thing that stops other people from getting effective EMF protection. And this thing is incorrect assumptions. Incorrect assumptions about what your EMF levels really are. Get clear on this. Get really clear on this. Remember, EMFs can't be seen, heard, smelled, tasted, or touched. And yet I knew they were there. In my home, in my office, in my car. I could feel them. Which felt like a curse at the time. But actually, it was a blessing. I'll speak more about that in another webinar. But so what did I do? I started to deal with them as best as I could. The obvious things. Stop using my cell phone, stop using Wi-Fi. In my case, I never had Wi-Fi in my home anyway. I ceased using my microwave oven. I went out and bought an EMF meter. Do you know what meter I bought? Okay, look at the screen. Look at your screen here. That's the meter I bought. Do you know what that is? That's the cheapest meter I could find at the time. The cheapest. That's what I bought. The absolute cheapest. I was sick. I couldn't get out of the house. I couldn't stay in the house. I was sick all the time. I was in a constant state of extreme fatigue, headaches, joint pains, lots of very unpleasant symptoms, and that's what I went and bought. Yeah. So I made a very half-hearted attempt at understanding my condition. I surfed the internet a little because my time was limited on the computer because of my symptoms. I didn't even buy a single book on the subject. So if truth be known, I didn't go to any great lengths to learn about EMFs and how to deal with them. And this was for a very good reason. Fear. Fear I was going crazy, fear that I wouldn't be able to understand EMFs and this would somehow make matters worse. Fear that reading about and thinking about EMFs by making me dwell on the problem would make my symptoms worse. It took me a long time before I did what you're doing today, facing up to things, applying rigorous EMF protection. That's what you're going to do if you've not already done it. But it was tough because I was having to figure everything out on my own because there was nobody to explain it to me. There was no courses, there was no knowledge. I didn't even know for 2 years that I was electrically sensitive. I didn't know really anything about these EMFs. What I hadn't figured out for a long time was that rigorous direct EMF protection was the foundation on which everything else was built. What do I mean by direct EMF protection? So I mean understanding, measuring, shielding from these EMFs. So if you look at your screen here. So this is an analogy. Imagine building a house without proper foundations. Initially your house looks solid. Any new house looks solid. But over time, cracks appear, and these cracks might eventually lead to your house collapsing. When a good foundation is in place, when all the other elements like strong walls, sound roof, electricity, plumbing, good workmanship, when all this is brought to bear, the result is a good, solid home. Even if you don't have much in the way of modern comforts, you have the essentials and the rest can be added easily. Ultimate EMF protection can be likened to this. Firstly, you need to establish a solid foundation of rigorous direct EMF protection. Once this is in place, you then bring the other elements that are needed to achieve indirect EMF protection into play. So just like a house with poor foundations which will be prone to cracks and eventual collapse, if you don't first apply rigorous EMF protection, then everything else you do to bring relief from EMFs will be compromised and have very limited effectiveness. So what's step one in achieving a strong foundation of direct EMF protection? Step one, it's obtaining reliable readings of your EMF exposures. How? By using a good quality EMF meter. What EMF should we try and measure in our environment? To get that good foundation, that house, look back at this house. To get that good foundation, you need to measure as effectively as you possibly can. Let's look at the EMF spectrum here to understand this better. Okay, look at your screen here. So the EMF spectrum is a way of understanding these different EMFs. As you can see in the diagram, it gives different names to different categories of EMFs according to their frequency, which is shown on the bottom scale. If you look down the bottom here, there's a black band with a series of numbers on it, 10 to the power of 6, 10 to the power of 7, 10 to the power of 8, up to 10 to the power of 21. That's the frequency band. Okay. If you look at the top of the screen, you've got the wavelength. Okay. So this EMF spectrum, it classifies according to their frequency. So look at the bottom, tells you the frequency, and the wavelength at the top. The relationship between frequency and wavelength, you can see here, is inversely proportional. Okay, so it might sound a bit technical, but it's not really. It's really simple to understand. So all I'm saying is that the higher we go in frequency, the bottom scale, so the higher we go in frequency, so on the bottom we're going from left to right. So as we're going up these numbers, 10 to the power of 6, 10 to the power of 7, etc. Then what you can notice at the same time as we go up the bottom scale, if you move along and look at the top scale where you are, we're actually at the top scale, we're going down, because we're going from 10 to the power of 3 down to 10 to the power of 2, down to 10 to the power of 1, and so on and so on and so forth, right down to 10 to the power of minus 12. So it's inversely proportional, that's all that means. So just below the wavy line is the wavelength, okay? And the wavelength, as you can see, is the distance between the peaks in the waves, okay? That's all the wavelength means. And below the wavy line, below the wavelength, is a bar which 2/3 of the way along, this thick bar that you can see, it's red, okay? And the other third is blue. And the 2/3 bit, as you can see, it's got written on it, non-ionizing. And it's this bit that concerns us. And everything below that is what's considered non-ionizing. Okay, you don't have to be too worried about what that means, but that's what and as you can see, the ionizing bit, that's all what we know, what's accepted, if you want, what's accepted by mainstream media and our governments. That is, everybody says, okay, that's dangerous. But the controversy is that our governments are telling us that the non-ionizing radiation, which are caused by things which are shown there, like home electrics, power lines, radio towers, etc., microwave ovens, our governments are telling us that the EMFs from those non-ionizing sources are safe. And this is the whole controversy, because of course they're not. And this is why you're listening to this today. So it's this red part of the spectrum that concerns us. And as you can see, this red part, it includes what's called extra low frequencies, or ELFs, and radio frequencies, RFs, okay, and microwaves, which is a subcategory of radio frequencies. So you can see these EMF sources along the bottom. And when I say EMF sources, I mean that's the things that generate these this non-ionizing radiation. So all these things, home electrics, power lines, cell towers, etc., all these things generate non-ionizing electromagnetic fields, okay, or radiation. So the first step, in rigorous direct EMF protection is measuring your home from these different sources. Okay, makes sense. Now this is easier than it might sound because these devices create EMFs which can be conveniently fitted into just 4 categories. Okay, I'm going to show this on the screen. The 4 categories. I know some of you know some of this already, but it's important to really that we're all on the same page here. So these are the 4 categories. So providing we have a means of effectively measuring our exposure to these 4 categories, we can then apply direct EMF protection and shield and protect as necessary. What this also means is that if you don't effectively measure these 4 categories of EMFs, you're dealing with a potentially significant number of unknowns, and your goal of achieving rigorous direct EMF protection will most likely be unattainable. You'll never achieve it. So I'm going to talk about what meters I recommend and why I recommend them. I'm going to give you a brief overview of the meters I recommend, so that if you don't already have them, you can order them. You don't have to buy these meters, but you do need sensitive, accurate meters capable of measuring the 4 categories of EMFs. Get clear on this, okay? Having the meters I recommend will make next week's, or the next seminar, should I say, the next webinar, easier to follow, because I'll go through each meter explaining exactly how to use it. So with EMF meters, it's very much a question of you get what you pay for. Some meters might sound expensive, but sensitivity and accuracy is everything with these meters. It's absolutely everything. A good meter in the right hands, that's to say with a little bit of knowledge, can go a long way. But a poor one, not only will it tell you very little, it can mislead you. So there are 2 types of RF meter, analog and digital. Most modern networks, cell towers, TV and radio broadcasts use digital technology, which is considered the most dangerous. You need to be able to accurately measure RF radiation, radio frequency radiation, because it's perhaps the most insidious form of EMF there is. Sitting in a deserted field, literally miles from anywhere and anybody, your EMF exposure to RF radiation could be very significant, because of radar, because of cell towers and different sources like that, military sources. Globally, it's the fastest growing category of EMF exposures. RF radiation is the fastest growing category of EMF exposures. RF radiation levels have skyrocketed in the last few years due to the development of what's called wireless technology. Yeah, things like cell phones, Wi-Fi, and so on. So if you look at your screen here, here's the meter I recommend for measuring RF radiation. It's called the Acoustimeter AM10. Now, I recommend this meter for 2 reasons. Firstly, it's broad frequency range. That's to say what it can actually measure, what frequencies it can measure. And the frequencies this meter can measure is 200 megahertz to 8 gigahertz. Let me explain. The frequency range of a meter refers to the frequencies that the device can measure. If you think back to the EMF spectrum, you recall that different devices work at different frequencies. Cell phones, for instance, work at high frequencies, and electric pylons at lower frequencies. But the same goes for devices, these devices that operate using RF radiation. They work at different frequencies. These meters work at different. One RF meter is not exactly the same as another in terms of the frequency range it measures. And many meters only measure in a very narrow frequency range. There's quite a lot of even quite expensive meters which only measure up to 2.5 or 3 gigahertz, which means that they're unable to measure the growing number of devices that operate at higher frequencies, 5 or 6 gigahertz. So that means you got your meter, you switch it on, it says there's no RF radiation, but there is, because it's just because your meter is not showing it, because it's beyond its frequency range. And also, some devices operate at much lower frequencies. For instance, some smart meters, wireless utility meters, they have emissions in the 400 megahertz band. And many RF meters are unable to measure this low, but the acoustimeter can. And the second reason I recommend this meter is because of its sensitivity. By sensitivity, I mean the degree of response. So the acoustimeter gives readings in two different measurements. Okay, I'm going to get a little bit technical here, but it's pretty simple. Okay, so this meter, the acoustimeter, it gives reading in volts per meter and microwatts per square meter. Okay, its measurement sensitivity, so it's got two columns. If you look, you can see volts per meter and microwatts per square meter. You can see that on the screen here. And so it's measuring up to 100,000. The definition is not very good, but hopefully you can see on the screen. It's measuring up to 100,000, so it goes from 1 to 100,000 in the right-hand column, and it goes from 0.02 to 6 volts per meter in the left-hand column of the meter. Yeah, you can see that on display. But what's particularly useful with the acoustimeter is its ability to measure true peak RF readings. Digital RF radiation is non-continuous. That's to say pulses, okay? And studies indicate that these pulses are particularly dangerous. They've got extremely rapid rise and fall times. The acoustimeter captures these peak signals and shows them in the LCD display in volts per meter, so the left-hand column, yeah. Most other meters that read power levels display approximate peak power, which is misleading. The acoustimeter measures the true peak reading. Now, this might sound like a small detail, but it's important because the acoustimeter provides much more accurate and valuable information. Because the other meters, they're offering average and approximate peak power. So they tend to give a lower than true reading. And that's really important. You know, that is critical if you're trying to deal with EMFs. If you've got a meter and it's not telling you half the things it should be because it's a poor quality meter, then it's a severe handicap. What I also like about this meter is that despite its sensitivity and accuracy, it's very easy to use. Using this meter requires no technical knowledge or skills. You can see on, how simple it is. You see on the right hand side, you've got the on-off switch and you've got the sound switch, and that's it. And you switch it on and you point. It's that simple. But this does come at a price. Okay, this meter currently sells on Amazon at around $470. 470, or you can buy it from EM Fields in the UK at £300 sterling, approximately £300 sterling. But this is a great meter, and it's my favourite RF meter. But if it is too expensive, okay, there's a solution, okay, and it's this. If you look at your screen, it's called the Acousticom 2. And the Acousticom 2 has the same microwave detector in it as the acoustimeter. It's also a lot smaller. You don't appreciate that looking at the screen here, but it's a lot smaller. It's like half the size of the acoustimeter. But it gives peak and average readings just the same as your acoustimeter, but it doesn't have the LED display. Yeah, it doesn't have that display on the top. If you look back at the acoustimeter, you can see we've got the display, the LED display. It's where it's written 5.29, 2.5 volts per meter, average, etc. So that's the LED display. So you don't get that LED display on the Acousticom 2. So the only information you do get is what's conveyed via the LED lights. Which doesn't give you quite as precise a reading, so you're not able to say exactly, there we go, what the reading is, but it is a really sensitive meter. So my first choice for an RF meter is the acoustic meter, but if that's too much for your budget, the acoustic COM2 is a good second best. The acoustic meter and the acoustic COM2 measure RF radiation, okay? Got clear on that. But this is only part of the story, of course. For ultimate EMF protection, you need to measure at lower frequencies also. We need to measure 4 things, you remember? Those 4 things: RF radiation, magnetic fields, electric fields, and dirty electricity, okay? So if we look at the EMF spectrum again, so you can see what I'm talking about. On the bottom left-hand corner of the spectrum, you can see home electrics and power lines. These are far to the left of cell tower and microwave ovens, etc. But the EMFs in question are at much lower frequencies, and because of the inverse proportional rule I was talking about before, the wavelength is much longer. In fact, the wavelength for AC current in the US is approximately 5,000 kilometers. Anyway, I don't want to get too much into the physics here because it's not important. It's really not important for what we need to achieve. I'm just telling you this so that you can appreciate that these lower frequency EMFs, or ELFs, as in extra low frequencies. Okay, there's lots of terms, I'm sorry about that, but you'll get used to them. So these ELFs are completely different, or a completely different animal to the radio frequency radiation, which is different again to infrared, ultraviolet, and gamma. Yeah. So there are lots of meters which can measure these ELFs. The meter I recommend is this one. Okay, if you look at your screen. Okay, and so this meter is the ME3030B, and it's made by a company called Gigahertz Solutions, German company, make lots of great meters. And this is one of their cheapest meters, if not the cheapest meter, but it's a great meter. This meter can measure electric fields and magnetic fields in your home and workplace. For magnetic fields, it gives a reading in nanotesla, which can sound a bit off-putting because most people are more familiar with readings in milligauss. And it's true, most EMF standards give readings in milligauss, or recommendations, should I say, milligauss. But nanotesla is actually a superior measure because it allows greater accuracy. It's a smaller grain unit. And for electric fields, the ME3030B gives a reading in volts per meter. Yeah, so it measures electric fields and magnetic fields. You can see it's got EM on the display on the left-hand side of the meter here. So what's so great about this meter? Well, it's the same as what I was saying about RF meters. Sensitivity is everything, and this meter is sensitive. It measures right down to 1 nanotesla. 1 nanotesla equals 0.01 milligauss. 0.01 milligauss. Studies show that there are biological effects from magnetic fields at just 1 to 2 milligauss. So this level of definition, it's not just nice to have, it's a real value. And this meter, it measures up to 20 milligauss, okay? Which, there's a lot of meters which measure higher, but if, you know, what we're interested in is measuring magnetic fields for health, and, you know, even at a few milligauss, you need to be looking for, well, anything over a few milligauss anyway, should I say, you need to be looking at solutions. So if it's maxing out at 20, or that's all you need to know. Maybe you've got 100, maybe you've got 1,000 milligauss, but if it's 20, it's already too much. So you need to do something. So the second thing that I like about this meter is that it has an earth cable for the electric fields, which is a wire you can see on the right there. Yeah. Next to the meter. This might not sound much, but it gives you far more accurate readings than any other meters which take non-earthed EF readings, electric field readings. It's a really simple meter to use, and it costs under $200. Okay, so it's not overly expensive. Yeah, there are meters which cost a lot more than that. A lot more, double, triple, thousands, okay, which do more or less the same thing. So this meter will allow you to take magnetic and electric field readings around the house from devices like your computer, your clock radio, electric oven, TV, electric wiring, your hairdryer, lamps, your dishwasher, your refrigerator, and so on and so forth. Okay, practically anything electronic, anything you plug in or anything with a battery. Okay, so I'm going to speak about the fourth category of EMF pollution. Okay, we spoke about three. We've talked about RF radiation, we've talked about electric and magnetic fields, and the fourth category. And the fourth category we need to measure is what's called dirty electricity. Now, dirty electricity is a form of EMF pollution in the kilohertz range, which situates down at the bottom left-hand corner of our EMF spectrum. So this dirty electricity is a form of EMF pollution that can exist on your house wiring. Okay, studies show that exposure to these frequencies can be extremely dangerous and lead to serious adverse biological effects and disease, things like cancer, diabetes, heart disease, neurodegenerative disease, yeah, like Parkinson's, Alzheimer's, and lots of horrible, unpleasant diseases. And the reason I'm saying this is because I don't want you to overlook dirty electricity. I overlooked it for quite a few years. I didn't think it was important, and it is. It's really important. So the most reliable and expensive way of measuring dirty electricity is with a device called a microsurge meter, okay, which is this meter, if you look on the screen here. So you just plug this meter. This is the simplest meter to use. You just plug it into your electrical socket, any electrical socket in your home or in your office, or wherever you want to test, and it tells you the dirty electricity present on your wiring. Okay, it actually measures it in the 4 kilohertz to 100 kilohertz frequency range, and it expresses this dirty electricity as a number. So there you see 14. So that means that 14 GS units. Okay, that's the level of dirty electricity, and it can actually measure up to 2,000 units. The recommendation is, the manufacturer's recommendation is that your GS levels should be kept below 50 GS units, okay, below 50. So these are the EMF meters I recommend. Now you don't have to buy these meters, okay, you don't have to buy them. You can buy other meters. What really matters is to stop making assumptions about your EMF exposures and obtain reliable readings. Yeah, stop making assumptions. If you haven't got the meters, you're stuck at step one. You need the right tools. Look, get the right tools. So you might decide to buy other meters. Instead of the acoustic meter or the Acousticom 2, you buy another supposedly good RF meter. Okay, but which meter? How do you know it's giving you reliable readings? How do you know it's sensitive? If you haven't got the level of sensitivity of the acoustic meter range of meters, how can you possibly achieve rigorous direct EMF protection or even basic EMF protection? Same goes for the 3030B. Same goes for the microsurge meter. I've been using these meters for years now. They're easy to use and they give reliable readings at a fair price. Getting the right tools is not an option. If you're serious about dealing with our EMF exposures, you shouldn't need any convincing about this. Having the right tools to measure your EMF exposures is the first step towards rigorous direct EMF protection. You can't skip this step. And once you've got these meters, the next steps are, number one, measuring and obtaining reliable EMF readings, which means using your meters to collect data, so you can then do something about it, take action. Number two, interpreting the readings. So that just means evaluating your readings in the context of your own sensitivity, how you feel, what your symptoms are, and in the context of safety guidelines and studies. And number three, applying EMF mitigation, which means using shielding and other methods to reduce your exposure. Yeah. So once you've got the meters, then we firstly measure and obtain reliable readings, secondly interpret those readings, and thirdly apply EMF mitigation. And these are the 3 topics I'm going to cover in detail in webinar 2. So to derive full benefit from webinar 2, you need to be able to reliably measure the 4 categories of EMFs: RF radiation, magnetic fields, electric fields, dirty electricity. If you don't have the means to measure these 4 categories of EMFs, you're back to making assumptions about your exposures, which are invariably the wrong assumptions. Okay, put it on your screen because this is really important. Your objective at this point is to achieve basic EMF protection. Okay, basic EMF protection. This is what your concern is, your number 1 concern. But the key is to apply this basic EMF protection in a very rigorous manner. At the end of webinar 2, if you follow and apply the information I'm sharing, you will have the fundamentals in place from which you can then go on and work on the other primary aspects of EMF protection. Remember our slide, the energy house, you remember? What I call, so you've got indirect EMF protection, direct EMF protection, and indirect EMF protection, that's stuff like nutrition, cleansing and detox, exercise and sport, and energy exercises. Okay, so firstly, let's get the foundation. Let's get this foundation. And it's vital that you concentrate on getting this good, solid foundation of rigorous, direct EMF protection. So there you have it. These are the broad strokes of my step-by-step guide to ultimate EMF protection. I wanted to keep it nice and concise in this first webinar. The follow-up webinars will be a little bit longer. I'm going to open up now the Q&A session and answer any questions you have on this.
I've got a question from William here, who's talking about asking me what ranges of magnetic EMFs are acceptable. So that's really the studies that tell us this. Magnetic fields, there's been studies going back over 30 years on magnetic fields. One of the effects that was first discovered was in relation to power lines, and not the big overhead power lines, but the kind of power lines you get in your backyard. And there was a 1970s study on this, which revealed a connection between these exposures to local power lines and magnetic and childhood. Now the levels we're talking about here are very low. We're talking about 1 to 2 milligauss, which is certainly, if you've ever played about with one of these meters, either the ME3030B or something like the Tri-Field, 1 to 2 is, for instance, the Tri-Field meter, which is another great meter, that goes, it measures up to 100 milligauss. So what we're looking, 1 to 2 is pretty low, and there are some well-documented adverse biological effects and association with disease at levels that low. So we've got a question here, let's see, looking through from Ellen. Let's see if I can put you on. I can see your hands raised. And hello, Ellen. Let's see. On mute. Okay. Ellen Anderson. Hello. Hello. And we don't seem to have any Ellen there. Any noise, but no Helen. So let's have another look down here. Got Scott here. Scott, who wants to ask a question. Oh, I'm going to switch on and off. There we are. And I'm going to go to you, Scott. Scott. Okay. Hello, Scott. Hello, Scott. Can you hear me? Got an echo. Hello, Scott. We don't seem to got the echo, but no, Scott. I don't know if you can maybe type something in, Scott.
Can you hear me?
Yes. Hello.
Oh, I sent my question in by what I thought was typed in, so I'll just say it out loud. Can you speak to the use of body voltage meter readings versus direct measuring in an electric field? In clearing my house of high-level electricity due to old wiring, I was directed to focus more on body voltage readings than direct measurements of ELF, for example, with the tri-field and other meters.
Okay. Okay. So your question, Scott, is about body voltage meter readings, if I've understood correctly.
That's correct. As opposed to using a direct measurement of electric fields with different other kinds of meters.
Okay. Okay. Well, I'll answer you on that. Yeah. Thanks for that question, Scott. I'm going to mute you because there's quite a bit of quite a lot of echo. Okay, so that's what I'll do with everybody. I'll take your question and then I'll mute you back off again. Okay, thank you. So I'll answer your question, Scott. So the question, Scott's put a question in about body voltage readings. Now, body voltage, we measure body voltage with something called a body voltage meter. No surprise there. Well, that's what there is such a device sold on the internet. But what I actually use is just a basic multimeter, which is pretty inexpensive. And so the thing to understand about body voltage is that you're measuring, as opposed to the differences with everything else I've talked about, these other meters that I've talked about today, the difference is that the other meters measure the EMFs in the environment, and the body voltage meter measures, it measures EMFs on you, or it measures voltage anyway, which is voltage is a measure of potential, electrical potential, and it's really simple to do to measure your body voltage. A lot of people, because there's a lot of talk about earthing at the moment, earthing or grounding, which means or can mean anyway, walking barefoot or using earthing mats and earthing sheets and so on. And one of the things I recommend if you are wanting to do that is to take a reading of your body voltage, of your electrical potential. And you can do this, as I say, with a really basic multimeter. And basically, so a multimeter, it can do lots of things, a multimeter, but basically by putting a multimeter on the voltage setting, the AC voltage setting, then you can measure the AC voltage in your body against the ground. So you're measuring the potential. All these meters are pretty, they've got pretty much the same design. You've got a red probe and a black probe. It's like on a wire, and so you would put the black probe to the earth, to the best earth you've got. For instance, if you're testing with a grounding mat, then you would stand, or you would test the grounding mat. For instance, you would put the black probe on the grounding mat, preferably on the metal. You would hold the red probe between your finger and your thumb, for instance. Just put it on your bare skin on your body. Make sure there's a contact, and it will be your AC in your body, so you can do the test first ungrounded, and then do the test again by standing on the mat and seeing what the difference is. And usually, well, you will, when you ground, that your voltage, your AC voltage drops. So it really all depends on where you are, where you live, and on your own physical makeup. You probably want to be on the millivolts setting because it will be quite low. But even very low AC voltages in your body, let's just say 0.5 volts. Serious effects in cattle have been noted because what this measures, this if you're getting 80 voltage in your body, that measures, it gives an indication of what we call stray voltage or stray current. And the other thing, the other side of this body voltage measurement is to measure your DC voltage. So you put your meter, your multimeter on the DC voltage setting, and make sure it says DC on it, and you do the same test again. What you should find this time is that by grounding, for instance, if you do the test with rubber sole shoes and then do it again, take another measurement without, barefoot on the ground, you'll find that your body voltage, your DC body voltage will increase. Yeah. So in one sense, your AC body voltage decreases when you ground, and the other sense, at the same time, the DC body voltage increases. Okay. So I've answered your question there, Scott. Let's see. Does anybody want to ask a question here? We've got some questions. So we've got one from Jennifer here. So Jennifer, what tips do you have for measuring? So priority what to measure? Priority what time to measure? No, what to measure? Time and logging. Good question. What to measure? There's no particular priority of what to measure. It's more about measuring those four things which I've gone through. To measure all those four things. Yeah. It's electric field, radiation, electricity. You can't say, well, there's no dirty. I don't believe in dirty electricity or electric fields. I'm pretty sure there's no electric fields. You can't make assumptions. You need to measure those four things. In terms of a priority, The only kind of priority you can put on this is, well, for instance, if you're living, right underneath a cell tower, then maybe you would say, well, I want to prioritize my RF readings. I'm careful about prioritizing, because what I want to really drive home is these 4 things you need to measure. You can't just pick and choose. Yeah, this is optional. It's, if you want to do it properly, you need to measure the 4 categories. In terms of time, well, you need to measure at different times of the day, morning, lunchtime, if possible, and evening, and different days of the week. On a weekend, what you get on a Sunday morning will not be the same as what you get on a Monday morning, most likely, for certain readings. Yeah, for instance, RF radiation, people are in bed on a Sunday morning, they're not going to be using the cell phones. When people are using the cell phones, then you expect your exposures to be higher. And you do need to log. And I'm going to talk about this in detail in the next webinar of exactly how to do this. I'm going to give you some handouts of EMF survey sheets for this, so that you can do this in as in a structured way as possible, and that's the important thing, giving structure to this whole business of EMF protection, and being systematic about it. Okay, so thank you for that question, Jennifer. Hope I've answered you there. Another question here. So I've got a question from Doug, who's asking, we have a tri-field meter. If we wanted to improve our abilities, would it be important to get the acoustimeter first or the ME3030B? Now, so the tri-field meter measures, it does a similar job to the ME3030B. The tri-field measures magnetic fields, electric fields, and it also measures radio frequency radiation, but it's not so hot. It's pretty insensitive for that. So the reason I didn't talk about the tri-field meter, it's a great meter, but the reason I didn't talk about it today, because in my view, for what you're trying to achieve here, that's to say ultimate EMF protection, the ME3030B is a better meter. So it's not to say the tri-field is a bad meter. It's a good meter, but the ME3030B, particularly for electric fields, it's a lot better. So there's no point, if you've already got the tri-field, okay, and you haven't got the $200 to get the ME3030B, then go with the tri-field, because it's great for measuring magnetic fields, and it will give you electric field readings, which are of value, but you don't want to be using it for the radio frequency radiation. So that's and the other part of your question. Would it be more important to get the acoustimeter? Yeah, absolutely. Yeah, get the acoustimeter. So if you've already got the tri-field, you need to get the acoustimeter, or if the acoustimeter is a bit beyond your budget, then the Acousticom 2. And these 2 meters, acoustimeter and Acousticom 2, they really are exceptional meters. I've used a lot of meters. I've got, in fact, I'm going to be doing a video on the I think it's the HFE35C, the gigahertz meter, which is a directional meter, and I've already been doing a little bit of testing on it, but because I just wanted to be sure, because I've never tested one of those before, I just wanted to see how it compared to the acoustimeter and the Acousticom 2, and the acoustimeter and the Acousticom 2 is, those are the meters you need, for what we're trying to achieve here, without doubt. Okay, so I hope I've answered your question there, Doug, on that. So I've got a question here from Lisa, who says, I belong to an EMF meter co-op group, and we collectively own meters, that's a great idea, Lisa, yeah. Our EMF meter is similar to your ME3030B, but more expensive, okay? I found that I get quite ill using that meter, although supposedly I shouldn't. I don't know if it comes from the grounding wire. Any advice on this problem, and do you understand why I'd feel ill using this meter? Well, it's not the first time I've heard that. There's no scientific explanation I can give you of why you would feel ill using this, meter. Using these meters, they don't concentrate, EMFs. They just read it. If they read what's there, there's a very small magnetic, they've got batteries in all these meters, so they've got a very small magnetic field, these meters they're safe to use. I've never had any problems using them, but I know, I've heard this before, and I'm not doubting you, but I think if you do have a problem using them, then you just get somebody else to use it. That's the thing. A friend, bring a friend, get a friend to help you take the readings. If it's a more expensive meter, I'm guessing it's a gigahertz solutions meter. And they do lots of great meters. The ME3030B is one of the cheaper ones. But yeah, I would going on what you're saying, I would assume that the meter you're talking about would do just as good a job as the ME3030B, assuming it's electric field and magnetic field meter. So I hope I've answered your question on that, Lisa. So just take a sip of water here. So I've got a question from William, who's asking, not quite sure what the question means, what he's trying to say here, but he's saying to me, over how much exposure time? So perhaps you'd like to elaborate a little bit on that, William, and I can answer you that. Got a question from Deirdre, I think. Deirdre, you said that. That's quite a long question. Okay, so the acoustimeter covers so this is what she's saying to me. The acoustimeter covers RF radiation. The ME3030B covers electromagnetic fields in our home, and the microsurge covers dirty electricity. Yeah, that's absolutely right. Now, what's the difference between magnetic fields and electric fields? Are those both with the ME3030B? Yeah, the difference between electric fields and magnetic fields. So electric fields is expressed in terms of voltage, and it's a measure of potential. Yeah, magnetic fields they exist wherever there is the current flowing. So the difference between there's lots of differences, but one of the big differences between the electric fields and magnetic fields is that electric fields are present. For instance, if you got a lamp and it's not even switched on, then there will be electric fields in that wire while it's plugged in, there will be electric fields in that wire, just as there are electric fields in your household wiring. For instance, if you're in a room and the lights are switched off, there will still be electric fields in those wires. And whereas there will only be magnetic fields when you actually switch the light on, and current is drawn. So you need movement of current. You need a draw, consumption of current to have those fields. And it's a little bit. I'm trying to explain this in really simple terms, and I hope I'm making sense and that you're understanding what I'm explaining here. But one analogy is with a river. So, for instance, voltage can be compared to the width of the river, and electric current can be compared to the speed of the river flowing. Yeah, so you can have a wide river but no current flowing, and so you wouldn't have any magnetic fields. So I hope that's answered your question. Are these both with the ME3030B, you're saying? And they are, yes. So the ME3030B, it measures both. It's got a little, I mean, it's really simple. All these meters I've talked to you about are really simple. So it's just got two buttons on it, and one switches it on and off, and it gives you the audio. And the other one, you switch between electric fields and magnetic fields. It's that simple. And when you want to test for electric fields, you need to plug in that ground wire, the one you saw in the picture, which is supplied with it. Okay, so I hope that's answered your question, Deirdre. And take another one here. Okay, so yeah, apparently there was a problem with the audio maybe at some point. So Ellen's saying, what does the acoustimeter read that is important? So the acoustimeter, that's the meter we use to measure radio frequency radiation. So radio frequency radiation means it's what things like cell phones, cell towers, microwave ovens, Wi-Fi, cordless phones, all those devices emit radio frequency radiation. And your acoustimeter, again, really simple meter, just there's an on-off button and there's a volume switch, and it's that simple. And then you look at the dials, you look at the flashing lights, and you look at the LED display, and it tells you it's deceptively simple because it's such a sensitive meter, and it's just so, you know, the design is really excellent, and it's you can really understand just by looking at the flashing lights. Basically, you've got colored lights, red, which means you know, very high readings, and then it goes amber down to green for lower readings, and you know that tells you it's really easy to identify RF sources with that. Okay, so thanks for that, Helen. I hope I've answered your question there. Okay. So Lisa is saying that she missed the answer to how to test for body voltage. Okay, because there seemed to be a problem with the audio. I don't know why that is, but I'll go through that again. So the body voltage, the difference, I'll go through it very quickly because I'm hoping that that most of you got this. But yeah, the difference between the body measuring body voltage and the other meters I talked about, they're measuring the EMFs in their environment, different kinds of EMFs, RF radiation, magnetic field, electric fields, dead electricity, in the environment, okay? And I use anyway, a multimeter to measure body voltage. Body voltage Again, so as I said before, voltage is a measure of potential, electrical potential. So it's measuring the electrical potential in your body. And as I say, we use a multimeter for this, really inexpensive multimeter. You know, you can pick them up for $30, $40, probably even less. So you're measuring on one hand you're measuring. So you've got two probes. Got two probes on these multimeters. They're all the same, and you've got a black probe and a red probe. And the black probe is the probe that we want to be putting to Earth, putting on something which is earthed. And the red probe is what you hold. And so you measure your potential, with your voltage, between these two probes, and it's that simple. So you've got two settings on these meters. You've got an AC setting, alternating current. So that's measuring the man-made EMFs. So you put it on the AC setting. It tells you exactly what your body voltage, what the AC current is in your body, what the AC voltage is in your body. That's what it tells you. This meter, this multimeter or body voltage meter, which is really important to know. And it also tells you, if you put it on the DC setting, then it can also tell you your the DC voltage. And the DC voltage is the Earth's, the natural EMFs from the Earth, if you want, the natural electrons. So we're looking for, an ideal situation is to have a high level of natural beneficial electrons from the Earth, and a low level of AC voltage. And this is one of the things that you can, I recommend that you do this. It's another meter, which is, it's really useful to have. But because it opens your eyes, as all these meters do, that's what they do. They open your eyes, and when you understand, when you actually see, seeing is believing. And when you see on this thing exactly what happens, what your AC voltage is when you're sat in front of your computer, for instance, well, it can be quite a shock. So that's why it's a good idea to have a meter like this and to be able to test in this way. So I hope that's answered your question, Lisa. I hope you got that. So we've got a question about solar flares. Have you ever seen an effect from solar flares, from William? No, I have not. So yeah, we are in the realm of EMFs. I've not seen, in my part of the world, we don't really get those. But yeah, I know that some people can be affected by solar flares, certainly, yeah. So yeah, the audio doesn't seem to be very good. Lots of people saying here, but there will be a recording of this, so don't worry. And if it is a horrible recording, or if the audio is horrible and the recording's not good either, then we'll do it again. Don't worry, we'll go through this because I want you to. This is the first webinar, so it's important that all this is really clear. Because this is the groundwork, this is the foundation of what you need to do to achieve your goal here of EMF protection. Okay. So I can see William wanting to ask a question. Okay, so I'm going to unmute you, William. Okay. Hello, William. So normally you should have William on.
Oh.
Okay.
Excellent. Can you hear me?
I can hear you, yes. Hello, William.
Can you hear me?
Yes, I can hear you, William.
Can you hear me there?
Yes.
Oh, okay, just 1 second. I'm going to switch it so you don't get an echo.
No,
Okay.
that sounds good.
2 seconds ago. Shouldn't be an echo anymore. Sorry that... Okay, the question was about the solar flares particularly affected, but I was wondering, as you were talking about the measurement tool, where in particular do you tend to measure? For example, we've had them by and gone through most part of the house. Where are you focusing for the highest effect?
So for the highest effect, sorry.
You know, is it a bedroom, or and then once you have those measurements, how do you go about in Shield?
Okay. So yeah. So your question is where you focus.
Well, once you have the device, you then make a measurement and then
take
the readings from, and then find a baseline.
Okay.
You know, you've taken the measurements, you've kind of recorded them a week.
Okay. Okay. Thank you, William. I'm going to ask you. I'm going to mute you back again. Okay. And I'm going to.
And then how do you deal with the
question? Where are we? Okay.
Excellent.
Thank you. So, great question from William here. So, talking about priorities for measurement and shielding. So, yeah, now this does go a little bit into what we're going to talk about in the next webinar, but it's really important and there's a lot to cover. So it's good, you know, that we move forward on this. So there is one room where you really you need to get things really. You know, your EMF exposures really down as low as you can. And that room is your bedroom. And your bedroom, well, in theory, it's a room where you spend a lot of time, at least eight hours. Hopefully, that's what I recommend anyway, but I know it's not possible for everybody. But yeah, it's really important to you know, to get your sleep, and your bedroom is a room which it's not just a room where you spend, you know, 7, 8, 9 hours or whatever it is. It's a room where your body in a cellular sense, it does its repair work. It's a room where your body can regenerate, rejuvenate, detox, and it's a room where if you sleep in the dark, which is really important, then your body can create a hormone called melatonin, which is I don't know if you've heard about that, but it's really important for one of the things that we know from the studies is that EMF exposures impact the production of melatonin. And melatonin is created by the pineal gland, and basically, if you're sleeping in an environment where you've got, you know, high EMF exposures, then your melatonin production is going to go right down, and it's just such an important hormone because it's necessary for proper immune system function, for cancer prevention, protection from heart disease, correct brain function. It's really it's a super hormone, and so this is one of the reasons why it's so important to get things right in your bedroom. So if there's only one room where you say, right, we're going to do what we need to do here, and we're going to, you know, sort these EMFs out once and for good, then it's the bedroom where you need to do it. because it's not like 1 hour in your bedroom equals 1 hour, you know, in your office in terms of what it's doing to your body. Because if you're sleeping in a high EMF environment, your body can't do all these things it needs to do at night. Your cells can't specifically. And over time, you know, this is where you're going to have health problems and possibly. And, you know, studies show this does contribute to certain physical issues and illnesses. So yeah, without doubt, the bedroom, EMF protection in the bedroom is the place to start. And so we're talking about shielding. So shielding really, as I say, I'm going to talk about this in detail next time, but shielding is a last resort. Shielding is a last resort measure for lots of reasons, because often it can make things worse. As what people don't realize is, and it's important to really understand this, because a lot of people, they kind of think, oh, I live near a cell tower, or my neighbor's got Wi-Fi, so I need to shield. And they don't buy a meter, or they don't borrow a meter, or they don't have a meter, and they shield, and they put all this, you know, metal shielding up, or paint, or whatever, and it actually makes their exposures worse, because the EMFs, well, the radio frequency radiation, you know, it gets in there and it just bounces around, and it reflects off all this metallic shielding that they put in there, and their exposures increase, and maybe they've got magnetic field issues as well. So yeah, that's just, as I said, I'll talk about that more in the next webinar. But shielding, that's really, there's lots to do before you, you know, start shielding, and there is a way to go about shielding. It's not just, you know, buying a bit of paint, shielding paint, and putting it on the wall and then hoping for the best. So I will talk about this more in the next webinar, but thanks for that question. So let's see, we've got some more questions here. I've got a question here from Doug about the tri-field meter. The tri-field has 3 sets of coils, so you can hold the meter in any orientation and get the same reading as the acoustimeter and the ME3030B. No, there's a difference. The difference between, so I hope you've understood the question I have, but Doug's asking about how the tri-field works compared to the acoustimeter and the ME3030B. And the difference is that the tri-field is omnidirectional. It's a 3-axis meter, so you hold it anywhere and it's taking in the 3 axes X, Y, Z all at once, and it's giving you a reading, it's calculating a reading. Whereas the ME3030B and the acoustimeter are unidirectional, so you need to move them around, and it's giving you a reading just one point, and it's not giving you, like I say, it's not calculating this X, Y, Z reading for you. Okay, so they are quite different. Not to say that the tri-field is necessarily better for that. It depends what you read. You know, you need to know how to use these meters. Obviously, use the tri-field differently to the ME3030B. They both measure pretty much the same thing. So yeah. Whereas the acoustimeter, I'd say it's pretty much an advantage that it's not omnidirectional, because it's not a directional meter, the acoustimeter, but it can give I find it can give an indication of direction when you're using it, which is really useful. Okay, so thank you, Doug, for that question. So we've got a question here from Jim. Is there any curvature in microwave wireless fields, or are they straight line directional? I wrap digital meters in aluminium foil, and it does a great job deflecting the field. Would an aluminium suit make a low-cost EMF outfit in a pinch? Yeah, big pinch, Jim. I'm not a big one for protective clothing. And we're going back to the thing here, which I was saying before, is because when you start introducing these very unnatural materials, which are invariably metal-based, when you start introducing them into a room or on your body, you get all kinds of things happening. And unless you measure that closely, you shield and then you measure. And then you see, okay, better, worse, you re-shield again, you measure. You shield, you measure, and that's how you go on. And the problem with the kind of wearing protective clothing is, well, you can't measure in your suit, or with very great difficulty, unless you've got a very big suit. So you don't know what you don't really know what's going on. You shield, but unless you can actually measure what you've shielded, if you can measure the result, then we're back to what I was saying before about assumptions. And the whole point of using meters and of EMF protection, of applying rigorous EMF protection, is doing it in a kind of this scientific, structured way, which I'm going to explain to you. So, for me, it's not advisable. What is advisable, and this is where this is the whole thing about the big picture, because we don't just look at basic EMF protection, which is what I've been talking about today. We look at these other things, and these other things are the changes that you're going to be making in your life. Nutritional changes, and detox and physical activity and energy movements, energy exercises. All these things have a major impact if you're electrically sensitive, which I guess you are if you're talking about suits, protective clothing. That's what I'm going to be explaining to you, is exactly how you can use these different techniques to address your sensitivity. And so no, protective clothing, I don't, really not a good idea, except in maybe exceptional circumstances. But no, not advisable. So thank you for that question, Jim. And I'm going to take another question here. So from Annette, I'm going to go on a little bit longer here, just to say first, I'm going to keep going with these questions as much as I can here, a little bit longer. So feel free to keep the questions coming on this. I want to try and cover as much as we can. Okay, I'm just going to take a sip of water. So Annette is asking, what's the difference between electric fields, magnetic fields, and dirty electricity? So, electric fields and magnetic. This is I know it's kind of difficult to understand, because whenever I talk about them, then try and explain these definitions, and we kind of get back to talking in technical jargon, which people have difficulty understanding. And I guess really the important thing to understand about these electric and magnetic fields is, just don't dwell too much on this. Understand that electric fields, that you're measuring them in volts per meter. Okay, with your meter, you've got your meter. You're measuring this energy form, if you want, in volts per meter, and it's a form of EMF, which is relatively easy to deal with. And Magnetic fields, on the other hand, is, like I said, when current flows. So we measure in milli-Gauss or nanotesla. And whenever we current flows, then we've got magnetic fields. For instance, power lines, huge magnetic fields, because there's a lot of current flowing, because they're, overhead power lines. They're going to be sending out power to a neighborhood or a town. And if you're living near one of those, then, very, very high magnetic fields. And so what's the difference between those two and dirty electricity? Well, it's a question of frequency. There's quite a few differences, but it's primarily one of frequency. That's the easiest way of understanding it. The dirty electricity, we're talking about higher frequency. We're talking about what's called intermediary frequencies, and so which is in the kilohertz range. And dirty electricity is, it's like a parasite which is on your electricity supply. The technical term for this is transients and harmonics, and it's also called noise. So you can have a nice, if you remember back to your physics school days, you've got this. You remember this nice clean sine wave. You remember seeing that on in your textbook or whatever, or maybe you had an oscilloscope or something where your teacher showed you that. So you get this nice clean up and down sine wave, like the one I showed you in the EMF spectrum. And dirty electricity is this sorry, the words got out of my head. Is a form of pollution which is carried along, which is a parasite. There we go. Let's go back in again. It's a parasite. It's like a parasite which is carried along on this wave, and it's the reason we call it dirty electricity is because of its effects on health. So it's like something which is there on your wiring, and it's measured by this very simple meter called a microsurge meter or a GS meter, and you stick the meter in and it gives you readings of dirty electricity. Okay, so I hope that's made things a little bit clearer on that. So, do I have a brand name suggestion for a multimeter? Yeah, I can give you that. Now, because, well, you see, I'll tell you the one I've got. The one I've got is a Martindale, but I think Martindale's a UK company because I bought it from a UK firm on the internet. But so I'm not sure you'll get that. It's a Martindale MM39, but I can give you another meter here if I can find it. Here we go. It's an Amprobe, AMPROBE, Amprobe 5XP A meter, 5XP-A meter. And I actually checked these meters out earlier today just out of curiosity, and they're actually $49 on Amazon at the moment. Yeah, so that's a good, a really good investment. Got another question here from William. What are acceptable ranges for normal AC and DC body voltages? Well, acceptable. I'll tell you what my readings were on this when I did it. Where is it? It's noted down here somewhere. Here we go. Yeah, so the kind of readings you might be getting. So in terms of AC body voltage, you know, 0.5, 1 volts is, you know, is nothing exceptional. And in terms of, so that's the AC body voltage reading. And in terms of DC body voltage reading, then it, you know, when I did this the first time, I had an on-grounder reading of 0.003 volts, and when I grounded, I was at 0.21 volts. And so, just to give you the full picture, when I was ungrounded on the AC setting, so I was at 0.7 volts, and when I was grounded, I was at 0 volts, which is about I was zero, yeah. So there we are. Okay. So yeah. Obviously 0 is very acceptable. If you've got no AC body voltage, that's very acceptable. Yeah, grounded reading for DC body voltage. So yeah, 0.20, 0.30 around there is, you know, pretty good. Okay, so thank you, William. Question here from Lisa. Okay, good, Lisa. I'm glad you've understood that. Okay. Okay. So got William who's willing to give me some advice on the audio situation. So yeah, I'd very much appreciate that, William. I think that's pretty much what we've got time for today. So I hope you've enjoyed this first webinar. It's been a pleasure having you on today. Thanks for attending. Thanks for your questions. I look forward to seeing you in webinar 2, which will take place on Thursday the 9th of January. My name is Lloyd Borrell. See you next time. Thank you.